What are the assumptions for the chi-square goodness of fit test? Number one, sample was selected or observed at random. So you just go and, bump into people at random and say, what's your major? Or let's say that you want to know how somebody's going to vote, whether they plan to vote Republican or Democrat. You wouldn't want to go to a Republican convention and say, how do you plan on voting? Because clearly that would not be observing or selecting people at random. All right. That would definitely be a biased sample if your intent is to really get a good idea of, how many people plan on voting Republican versus Democrat. So instead, you would just want to go to, I don't know, Walmart, all right, some random town, hopefully a number of random towns, and then ask people there whether they plan to vote Republican or Democrat. Now, the expected frequency for each category is at least 5. So I alluded to this a few minutes ago. It's one of the assumptions of the chi-square tests, both tests, in fact. And what it's saying is that the expected frequency for each category will be at least 5. The expected frequency is not the frequency that you observe. It is not your data, the number of people you counted. The expected frequencies are either given to you, all right, there's some other distribution maybe that you want to compare your observed frequencies to, and so you just look up these other frequencies. Those would be expected, okay? It's not you personally observing them, they were given to you. Or, they're calculated based on some theory, right? So SPSS will calculate the expected frequencies. And those frequencies, again, you need to have at least 5. They have to equal at least 5 for every category of your variable. And then the last assumption is that regardless of what you're counting, if you're counting people or if you're counting animals or things, whatever it is you're counting, they can only contribute data to one category. So if you approach somebody and you say, how are you going to vote? And they say, I'm going to vote Republican and Democrat and Independent. Well, first of all, good luck with that. But let's just say, in theory, they could. You can't include them, right? Because each person or thing can only contribute data to one category. All right? What are the hypotheses? In terms of being, directional or non-directional, we always phrase them as non-directional. So we always phrase them, in such a way as to say that the frequencies will be equal across all categories. That would be HO. HA would be the frequencies are not equal across all categories, right? That would be for the first example of when to use the goodness of fit test. In the second use of the test, where we're comparing the observed frequencies to some other distribution, right? HO would say that the two distributions are the same, and HA would say that the two distributions are not the same. Okay, so those are all non-directional hypotheses. Now, technically, chi-square tests are also just one-tailed tests. And that's because chi-squared, right? You cannot have negative numbers. Although arguably in some distributions, the ones that have a lot of degrees of freedom, it looks like they could in fact have two tails, right? If they look to be roughly normally distributed. If you go back a few slides, you'll see that, remember that red-shaped curve, that red-colored curve? There would be two tails in that situation. But most people argue that because it's a squared number and you can't have negative numbers, it is always going to automatically be a one-tailed test, okay?